All right, welcome back to another fun edition of Algebra 2 PLP. And this time we're going to be talking about inverse functions. Okay, inverse functions are functions that undo each other. Okay, the input of one function and the input and output of one function become, and they switch, are the then output and input of the next. So the input of one becomes the output of the other and vice versa. Okay. So there are 4 easy steps when finding an inverse listed right here for you. The very first thing we're going to do is replace f of x with y, because f of x is y. So we're going to have y equals 3x minus 1. That's the same as the original function that you're looking at there. And then we're going to switch the x and y. So when the x and y switch places, we're going to end up with x equals 3y minus 1. And you're going to solve for y. That's it. So we're going to add our 1 over. And then you're going to divide everything by 3. Okay, so you can have x plus 1 over 3 equals y, or you could divide each piece by 3 and get 1/3 x plus 1/3 equals y. Okay, and the last thing you want to do is replace the y with f inverse of x so that you know that you're talking about the inverse of the original function. And I would take this statement here, 1/3 x plus 1/3, or x plus 1 over 3. You could leave it as either one. This would be an equivalent statement. I'll take either one. So you just need to know that they're the same. So again, over here, we're going to change our g of x this time to y equals. We're going to switch x and y. So now I'm going to change colors. That way I know that I'm working with the inverse function. We're going to get rid of a square, use square root both sides. And anytime you square root both sides, remember you have to put the symbol plus minus. Okay, we have to subtract our 2 over. And because of the plus minus, I'm going to put that second. Otherwise, it looks kind of funny. So I'm going to put -2 plus minus x, square root of x, equals y. And we would rewrite it in function notation. This time they used g of x. So this time instead of f inverse of x, it's going to be g inverse of x. So that you know which function we're talking about. And it's going to equal -2 plus or minus the square root of x. Number 3 here. Again, we're going to start by replacing this as y equals the cubed root of x minus 5. We're going to switch the x and y. And now we're going to solve for y. The very first thing, since the whole thing is being cubed, we have to take both sides to the 3rd power. So we end up with x cubed equals y minus 5, because the 3rd power cancels the cubed root. And then we're going to add the 5 over, which in turn, now the last thing to do is state that that is the inverse function that we just found. Okay. And one last time here, you're going to change your f of x to y. You're going to switch the x and y. Okay. You're going to move your 2 over. So it's x minus 2. You have to get rid of the negative, which is essentially just going to change all of your signs. So you get -x plus 2 equals y squared. You multiply or divide both sides by negative. And then you have to take the square root of both sides. And again, when you take the square root of both sides, you have to put the symbol plus minus. We're going to get -x plus 2 equals y. And again, name it the inverse function. Lastly, they ask us to confirm that things are functions by finding inverses. Okay, if you do a composition of functions and you get x both times, it has to happen both times. So if you do it and it doesn't work on one, then you don't have to check the other. But if you get x on one, you do have to check the other. Make sure that both f of g of x and g of f of x give you x, and to determine whether or not it's an inverse function. Okay, so here I'm going to start with f of g of x, which means I'm going to have 3 times that whole thing, x plus 1 over 3, and then I have the minus 1 out behind. Okay, so what just happened there was this went in for this. Okay, and we end up with these 3's canceling, and we get x plus 1 minus 1, which is just x, which is what we wanted. Because that one is x, we need to check the other direction. So we're going to this time check g of f of x and make sure that it also gives us x. So this time, we're plugging this in for this x. Okay, so in place of that x up top, we have a fraction, and we're going to plug 3x minus 1, and then we still have the plus 1 over 3. And on the top, 3x minus 1 plus 1 just becomes 3x over 3, and the 3's cancel, and we end up with x. So because we did composition both directions and we got x both times, our answer is yes, they are inverses. Okay, one more example like that. Again, we're doing composition both directions. F of g of x, 2x minus 10 over 2, and then we have the plus 5 out. Oh, the 2 is part of the original, plus 5. So if we divide everything in that first one, we end up with x minus 5 plus 5, which is x. So now, because that one was x, we need to check the other direction. So this time we're going to do g of f of x. And in place of the x, so we're going to have 2 times this whole f function, which is x over 2 plus 5. And then, and then minus 10 out back. Okay, if we distribute that, the x times x over 2 just becomes x, or the 2 times x over 2 just becomes x, plus distribute this, we get 10 minus 10, which is x. And again, we got, yes, they're inverses because both times we got x. If one of them doesn't equal x, then your answer is no, they are not inverses. All right, lastly, that is how you find inverses of functions with it's just an x and y. If they are real life problems, like real life problems where your variables are defined, you can't just switch them, okay? Do not interchange the variables because the variables are defined and have meaning attached to them, okay? So all you're going to do is just solve for the other variable. So when they ask us to find the inverse of this first one, it just means solve for m. So how are we going to get the m by itself? Well, the 3.28 is attached by multiplication, so we're just going to divide it. Okay? And that means that we get the statement m equals f over 3.28. Okay? So meters equals feet divided by 3.28. So on B, when they say use the inverse to find out how many meters are in 5 feet, we're just going to plug 5 in for the f. And rounded to the nearest hundredth, you get approximately 1.52 meters.